So I'm Florian. I'm here today to talk about how at Qonto we are tackling tech debt at scale. I've been a software engineer for the last 15 years now, and the common denominator of my previous role that we had some pretty small team, I would say up until maybe 15 engineers, which is still sound quite big for mobile. But when I moved to Qonto, and the context radically changed. So I'll just start quickly talking about Qonto. So Qonto is an app where you can get an online business account, and then you have all the tools you want around. So invoicing, bookkeeping, spend management, and we offer this for freelancer, but also for small and medium companies. Clear pricing, and we have real 24/7 human to help you with our customer support. And so to give a bit of context, what I mean by at scale here, our team as of last week consists of almost 100 engineers and 9 leads. So a lead at Qonto is pretty much a manager, but that's also technical. And we have pretty much the same thing on iOS, and we are all split in 13 different teams that themselves are split in 4 domains. So it sounds like a lot of engineers for one small app, but actually we have a pretty interesting context as well. We are in 8 different countries. Each country have different regulation. They might need some specific features depending on their regulations. We also serve different tiers of company, right? So freelancers have different needs than small companies, which have different needs than medium companies. And then the app can be experienced also in different ways, depending if you're an employee, a manager, an owner, or an accountant. So if you multiply all of this, you can start to understand that we actually need to create a lot of features for a lot of different people and different use cases. And to give you also a bit of an idea of our code base as of last week, we have 550 modules. We are probably going to double this soon because we are splitting them in API and implementation modules. We have over 1 million line of code, and we are shipping 300 PRs a week around. So that's quite some code. So what's interesting is that we are not really a startup anymore, but we're also quite far from being big tech. But we're also starting to hitting quite some interesting scaling issues. So there's multiple ones, but here today we're going to talk about tech debt. So the problem. So let's say you're a new engineer starting at Qonto. You're starting, and you spend a couple weeks / month familiarizing yourself with the code base, getting used to how your team operates, so how the architecture look like, how people ship, and all these kind of processes. And you start slowly but surely shipping feature yourself with the right amount of speed and quality. And of course, because you're good engineers and you want things to stay clean and sharp, you also clean up the code as you go, as you created new features. But the problem now is, at the scale we are at, how do you know that the code your team owns is doing good actually? We have team that's been there since the start of Qonto that maybe own 70 modules, but we also have smaller team that only own just a few modules. And at this scale, how do you know that all this is doing good, right? How do you know what's the most pressing issue to solve, right? Maybe we are doing a migration. Maybe there's things in the code that you own that you need to fix, but it's not very clear where those things are and how to see them. And most importantly as well, maybe we are doing a pretty big migration, right? Maybe we are moving from one framework to another, and maybe only in your team's code there's still some code that is making the migration not happen, right? And this is not something you can really visualize or know, except if someone go dig in the code and really go tell your team, hey, you need to fix that. But it doesn't really scale with 60 engineers. And then I guess probably quite some of you have this tool, SonarQube or something equivalent, and you're like, sweet, I can just go on SonarQube and see whatever is reported by my static analysis tools, right? So you open SonarQube and it tells you, okay, you have 2,000 issues. Awesome. And then you try to click around and you're like, okay, this is the kind of issues I have. But the problem here is that you cannot really, without going really manually, module by module that you own, see, okay, I have this type of issue in this module. This is where they are. This is how I can fix them. So it's very manual and not really super helpful. And the consequences of that is that it's quite discouraging, right? So how can I fix something if I can visualize it? The depth doesn't decrease. Worse, it increases slowly but surely. So then this means you have this endless discussion every week, you know, with the ceremonies you have with your team, where it's like, oh, we should do something about the depth, right? It's getting bad. We have all of this magic number on SonarQube that goes up. We need to do something about it. And then the truth of that is that because depth is everyone's problem, it's also really, in the end of the day, it's no one's. And this is the state of what we called at the time depth, right? So for us, depth was mainly at the beginning, at least, just whatever is reported by detect and Android lint. But we'll see after that we added also other kind of depth. And you can see here, quite interestingly, that the more we grew and the more engineers we got on the team, then the more issues were reported. So that looks pretty bad. So how do we go now about finding and building a solution for that problem? What do we actually really want? We really wanted to improve the ownership of the depth. We wanted that each team is really the owner of their module, which means that they also own whatever depth is in there. And to be able to do that, we need each team to be able to visualize that depth and also to understand what's the priority, right? Because maybe you have, I don't know, a detect tool that say, oh, you have a unused import here, but it might not be as important as we need to fix this to be able to be compatible with 116 next week. So we need a way to enable that prioritization. And overall, the end goal is, of course, to reduce the depth. But we also have, as I mentioned, we don't have infinite resources. So we have a big team, but we don't really have anyone that's, like everyone is basically shipping feature, and we don't have platform teams. So we need to figure out with our constraint how we can start and build a solution that works for us. So what we wanted to do is we wanted to start with something that's cheap, right? We don't want to spend months building something and discovering at the end that no one is actually going to use it. So we wanted something very cheap that we can, create in a couple of weeks. We wanted to get this version out fast. We wanted to try, okay, does this work in the team? Do people actually use it? And to be able to iterate on it afterwards. And we wanted to bring this value straight away. Again, not starting a project for 6 months, building something obscure, maybe over-engineered, with way too many features, and then when you launch it, it's like, well, actually no one is using it. So that was the constraint we had. And then we had a few problems to tackle to understand how we wanted to build that. So one of the problems we had was the ownership. So we had a very basic understanding of ownership. So in each of our modules, we had a README that says, hey, this feature belongs to team X. But when looking at that, we realized that we still had 20% of our modules that actually didn't have an owner. So we had like very old modules that no one on the team really understood what was in there, like very old feature. Or we also had this like kind of more library modules, like for instance, which team owns, I don't know, the network module or the pagination library module or stuff like that. And we also had this monolith, right? I assume some of you have also one of these interesting modules that's full of really old stuff that no one wants to touch. And this was like pretty big. It was almost 1/4 of our code base at the time. But then we realized, okay, the goal of this initiative is actually not to fix the ownership. We already have a certain amount of ownership, and we can start by leveraging the issues that are in this module that have owners, and those could be starting to be tackled. And then we also figure out that actually we could use this initiative to also surface the lack of ownership, right? So we'll see a bit later how we did that. The second problem is where do we get this metrics actually? Where do we get this magical depth? So as I mentioned, we started with something quite simple, which is the output of our static analysis tooling. So we have detect, Android lints, and we also have a bunch of custom rules that work for the context of Qonto. And we wanted to have a solution that is flexible enough so later on we can add different type of depth. But so where do we get it from? So the option one was to create some custom tooling. That's actually what they've done at Slack. There's this really interesting talk that I've listed here. But as I mentioned, we don't have the resources that Slack has. So we don't have months to spend with a team really dedicated to that problem. So we wanted to really start small and bring this value quite fast. And then the second option was actually the easier one, that we already pay for SonarQube. They have a pretty good API, and we can get all this information of like where an issue is reported, to which piece of code, and this we could map it to a team. So that was the easy solution. And then the last problem we had is how do we display that data? How do we visualize it? Our first option is Notion. At Qonto is quite interesting. We're actually pretty much only using Notion for everything. So the obvious kind of like answer was Notion, but at the time it was not handling graphs. I know that now it does, but it's still pretty basic. And we would have also needed some extra synchronization between where we store the data and Notion. And so the option two as well, we will use another tool that's called Metabase. That's a lot better at handling and visualizing this kind of data, and it's already connected to the database we are using. So that was also a tool that was already existing for us and that we are familiar with. So I just went with that. So to summarize, for the first prototype, what we wanted to do is to empower each team to be able to visualize and act on the depth they own. For this, we leverage the data from SonarQube. We format and store it to our mobile metric service, which is just a fancy word for a database with a REST API in front where we can just insert and get data from and display it using Metabase. Of course, we have some definition of success to make sure that we don't build something that's useless. And we had a pretty interesting objective of trying to get 90% of the team to reduce their tech debt by 50% in the next 6 months, and also to stop having manually tracking code-based wide migration. Because up to this day, whenever we had to do a code-based wide migration, we had to kind of like go in the ID, figure out all the points that needed to be refactored, maybe list that in a spreadsheet or on Notion. And the problem is that the code is also something that moves, right? So we had to repeat this every week, and it was just very time-consuming and very error-prone. And we never really needed at an instant T. We never really knew where the migration was. So we want to stop having to do that, and we want to be able to see it in real time. So just to show you a bit the solution, high level, how it works, to see that it's really not that complicated. What we already had in place is that people merge their code to develop. It's been some job on the CI that upload the data to SonarQube. And what we added in red is basically that once this data is uploaded to SonarQube, we fetch it, we format and we store that data in our service. And then we have our dashboard on Metabase that just use that data to render what we need. So it's a very simple solution, and it, up until now, has really worked quite well for us. So this is the early kind of like sketches on what we wanted to display. And this was quite interesting to help us like understand what kind of data we wanted to insert in the database to be able to create these graphs. And basically what we have is a dashboard that goes to the really global team level where you can see all the teams, and then you can drill down. You can click on the team, you can see their score, their issues, and then you can go at the module level, the issue level, and the file level as well. But there will be a demo later on, so I can show you a bit more how it looks like. This was the early prototype. It was very simple. Just whenever we had an issue was -1. So that was the global health board here. And what's interesting here is that we can see that actually by leveraging the data, we could also create like a fake team that didn't have any owner. And to the surprise of no one, actually, the modules that are not owned are the modules that are doing the worst in terms of debt. And then, as I mentioned, you can drill down. So here we can drill down in a specific team and see their module, their issues, what they're solving across time. And then we can go to the module level and the file level. And the last one that's quite interesting to follow this code-base-wide migration is that here we can have a specific issue that we can input, and then we see how much is done. And we can list where things are missing and in which team maybe they need a bit more effort to go through, or maybe we need to help them find that time so they can tackle this migration. Right, so now that we created like a little POC, spent a couple of weeks on it, we wanted to make sure that this was actually useful and that people knew how to use it. So we organized a bit of a little beta testing. We tested it on a smaller subset of teams. We gave them some little tasks, like for instance, find this type of issue and fix it in the code base. We gathered some feedback from them. So we mainly asked ICs and manager to play with the tool. They came back with a few feedback that we could implement that were quite easy. And for the rest, that was maybe a bit harder. We just logged it somewhere and came back to it later on. We found a name that sticks as well. It's a bit long, but people like it. And one thing that was quite interesting is that actually the dashboard, they started to leak to other teams that were not part of the beta testing. And other teams started to use it even though we were not officially part of the testing, which was a pretty good sign. Let's talk now a bit about adoption across the team. So we spent a lot of time communicating about it. We created a dedicated channel on Slack. We also created a cockpit, which is a fancy name for like a Notion page with all the documentation that regroups all the documentation and all the information about it. And I did also a lot of documentation on like how to access it, how does it work, how can you contribute to it, and this kind of things. We communicate it in our weekly. We try to communicate it in a way that's not like, please use our tool, but more like, look, there's this team that managed to fix all these issues. And we also shared some wins around, for instance, when we were completing migrations, or we were sharing also, here we are 50% through the migration to be able to, for instance, be compatible with Android 16. We listen a lot to the feedback and log all the improvement and the ideas that people had. We also added a bit of gamification, which was quite interesting because it did work quite well on a subset of the engineer that got competitive around like, okay, look, I managed to fix my issue in my team, or this kind of thing. So there's like a bit of back and forth on Slack with some screenshots on what people managed to achieve, which was quite interesting as well. We iterated quite a bit on the score. You've seen at the beginning we had this score that didn't really mean much. Like if I have minus 300 on my team, is that a good score? Is that a bad score? So we introduced like an easy to read score that's from 0 to 5. We made it a bit more fair as well because, as I mentioned, we have teams that have a lot of baggage, like a lot of old modules, whereas some are really new and only have a couple. So we kind of like pondered the score relative to the number of modules you were owning. We introduced coefficient. As I mentioned, we don't want to have people like fixing. I mean, it's not on the same level to fix like an import than to fix an issue that on a migration that we need to finish next month. So now we can say, okay, this issue actually is a 5, or this issue is a 1, or we don't really care about this issue for now. We put it at 0, which means that people, when they go on the dashboard, they naturally go for the issue with the higher coefficient to increase their score more than the lowest one. And now that we can actually visualize things as well, we realize that we have a lot of rules that don't really make sense and that don't we don't want engineers to spend time on. We basically had all the default detect rule, all the default lint rules, and so we had a little committee going through every single rules and deciding which one we want to keep and which one we want to throw. We also involved the team quite a bit. We encourage the engineer to write their own rule. We supported also the engineer that wanted to build around the health board. So I'll show you in the demo, we actually had engineer building blocks for other type of debt we have as well. And we made it very easy to report issue by introducing an annotation. So now they could just slap this annotation with a specific ID on any piece of code that had a problem. And any piece of code that would use this annotated piece of code would be reported as an issue with a clear message on how to fix the issue. And it was just straight up on the health board without much to do. Let's have a quick look at the results. So in terms of the definition of success, we actually managed to get that one in less than 3 months. So in less than 3 months, we really saw a lot of excitement around the tool. And most of the team actually really worked hard to reduce quite a bit their debt, which was amazing to see. We now have a tool where we can track automatically migrations. So whenever you merge to develop, that number is updated. And we don't have to manually deal with spreadsheet or Notion database or whatever. We just go on the specific issue dashboard and we have the number we want to. All right, I've talked so much about it. It's time to actually have a quick look. Let's see if the demo works. So can you see? Yeah, maybe it's a bit small, but so this is the global health board. So you can see here we have all our team, our 13 teams, and we have their score. And we have kind of the evolution over the last month or so of how the debt evolved. I was mentioning that we have engineer actually building over blocks. So we have 2 at the moment. We have one around our UI test. So recently we introduced a new framework for our UI test. And so there is a migration to do for all our UI tests, which before would have been also a nightmare to track. But now with a bit of code, we can just upload all of this data to the database, and we can visualize here which team managed to finish the migration and which team might need some help or support to finish theirs. We also have everyone's favorite thing as well. We have flaky tests, flaky UI tests, so those are also automatically reported there, and each team can visualize the one they need to look at and fix. We have the same for the dependencies. So we had a problem also with dependency not being updated fast enough by the team. And so now each team is owning also dependencies, and we can visualize here the one that needs to be updated. And so this is globally, but we can drill down, obviously, at the team level. And this is what a team would see. They would see their score. I was talking earlier about gamification, which is here. We have these little badges whenever you finish to remove a critical issue. So for instance, last year we got rid of data binding finally. We had to migrate our 200 plus activities to edge-to-edge. And there's a bunch more issues here that are linked more to Qonto and its context. Obviously, you can see the issues. Here, this team is doing quite good. So they only have issues that have a coefficient of 1. But otherwise, if there was higher up issues, they would show up at the very top, and people could just fix them. And again, in the context of this specific team, we have the migration of the UI test, we have the flaky test, we have their dependencies, and there's something that's still work in progress, but we're working also as I mentioned, work in progress. But this one is about also gathering data for each of our modules to understand maybe the one that are too big, the one that should be split up, or the one that have too much inward or outward dependency, which is also a problem we start hitting. And so the thing I was talking about as well, one of the most important functionality of this health board is to be able to track this migration. So for instance, one of our engineers recently was looking at Android 17 and bring a whole lot of interesting things to fix. And one of them is around the way we use the API for going back. And so he just created a custom lint rule that report this issue. And here we can see that we are 35% done. And we can see all the kind of like the instances of this violation in the code base. We have also this interesting feature here where I can click and it will directly open Android Studio at the right line and people can just fix it, which remove a bit of this kind of like friction between having to go to Metabase and fixing something in Android Studio. And then we can see also in the global way here, so we see for this specific issue, there's only a few teams that are concerned. We can see which team has the most issue, might need some help. And we also have this kind of like weird looking graph that tell us which team kind of like already fixed the problem. So we see spend management here in red fixed the problem recently. But we can see maybe, for instance, that account receivable hasn't really started on that. So if it was something that was timely, that we need to fix fast, we could then straight up ask them where they're at and if they need some help to figure this out. Right, I think that's it for the demo. I can come back to the presentation. So I have 15 more minutes. Yeah, okay, awesome. All right, so obviously we have quite some learnings. So what worked quite well is here is the iteration. So I think today this project is now a year and a half old. So we started really small. You can see the difference between the POC, the proof of concept we had at the beginning, and now how it evolved with different type of depth. So we really started small. We saw that the value was here, and we started to build on top slowly but surely. Don't underestimate this small feature. So the C in Android Studio button that I just showed is something that I built without much thinking, but it's constantly something that people love because they can just click on it, it just open the ID at the right place, and they don't have to be like, okay, so it's in this file, let me go to this file, okay, it's at this line, let me go to this line. They can just straight up see it. One thing that I would stress, though, is that it's important to keep it positive and avoid blame with this kind of dashboard. So we really use the score as the indicator that a team needs support, rather than blaming them for not having a good score. So this is something you need to make sure that you have at the heart of your company, or maybe work around it before you build a tool like that. Of course, because this day no presentation is a good presentation without mention of AI. I did actually use quite a bit AI for building this, especially because the SonarQube API documentation is horrendous, so it's quite good to have AI go through it for me. And they are also really, really good at SQL queries. So you can be like, here is my schema of my table, here is the kind of data I want to see. Please give me a SQL query, and then you can just paste it in Metabase, and it usually works from the get-go, which is quite nice. And so what we adjusted is that one of the problems we had is that we were constantly adding new rules, changing the coefficient, which means that the team would see their score just going crazy the whole time, which was really frustrating because they were maybe working really hard to make it better, and then the next day we were like, okay, we slap a 10 coefficient on this new issue, and then it would go back. So we realized that teams needs actually predictability. So now we changed the rule or the coefficient that will affect the score only at the end of the quarter. So people have a whole quarter to get back a good score, and then at the end of the quarter, then they start again if they have new issue popping up. You also cannot add or implement every request. Some people got really excited about the health board and wanted to add a million things. So for this, I really encourage you to log the request, because at the beginning I was saying like, yeah, we'll implement this at some point, but if they cannot see that you actually take this into consideration, it's also a bit problematic for them. And what worked really well is actually to encourage people to do it. So instead of doing it yourself, encourage people to do it and offer some support. So that's how we got this really good contribution around UI test and dependencies. What we're still figuring out is how to write a good lint rule. So we've had problem with people writing lint rule that would add, I don't know, 2,000 issue in the code base. So for instance, we had an engineer that wanted to finish the migration from GNU 4 to GNU 5, and he wrote a rule that was yielding like one issue per import that was GNU 4. I think it generated 2,000 or 3,000 issues. And what we realized actually is that we would just want people to migrate classes, test classes one by one. So instead of reporting 10 issues because there's 10 import in a file, we actually want to just report one. So we're still trying to figure out how we can help engineer like writing good lint rule that generate the right number of issues to not overwhelm the engineer, which I think is the second point. And some of the teams are also not as focused as other on the health board. So chatting with them and trying to understand what doesn't work for them or how we can help them get onboarded. So now let's look a bit at the future. What we are doing at the moment is we have even other ideas of other dimension of the depth we can add. So one thing we have is we have a bit of an issue with the size of the app. So it would be really interesting to be able to understand how much megabytes each team is contributing to the final APK. So they can potentially work on reducing that. As I showed as well, we have in the work at the moment some work around data for each module to understand the one that might need to be broken down or where dependencies need to be inverted. We are supporting also other stacks at the company to integrate the health port. So at the moment, iOS is playing with it and integrating it because actually we build it in a way that is quite platform agnostic. So that's also quite interesting. We want to reduce friction, as I mentioned. Like there's still this small friction of like always having to go on Chrome and then looking at the issue you want to fix and then going back to the ID and then fixing it. And so there's this annoying back and forth. We recently created an ID plugin, so we could just integrate it in there, and then you'll be able to just tackle your team depth while still staying in the ID. And then the other side of it, as well as quite interesting, is how we can actually automate this tech debt to reduction, right? Because when you think about it, it's not very brainy, it's not very interesting, right? You don't want to have to, I don't know, for instance, I was mentioning this migration where we need to change the way the on-back dispatcher is handled in each screen, or when you think about the edge-to-edge, ideally someone else would do this for us, right? So in terms of step, that's where we're at the moment. So we can now visualize the depth. We actually automated some of the easy ones. So we have, on Detect, you have this tool where it can auto fix some of those. So we have a CI job that turns every week, fix all the ones that are easy to fix, and then we just merge it. And where we're at now is that we are trying to also automate some of these issues using AI. So we are able at the moment to run the AI on the CI, and ideally what you would be able to do is to click on a button and say, okay, please fix this issue, and then it would just open a pull request for you that you have to review and then just merge, right? So then the engineer would have more brain power to actually work on things that really matter. And so for that, what we have in mind, it would be interesting to build like a MCP server that would be able to talk with the CFT health board, right? To understand, okay, give me the issues from my CFT, give me, I don't know, the commit where this type of issue is solved so I can learn how to solve it. We could also say, okay, now whenever you write a new custom lint rule, then you have to add also a prompt to it. So then we could use that prompt to fix those issues. And then in the end, what we'll only have to do basically is to review whatever is done by the AI and fix it if that's needed. So that's what we're aiming for, to have people actually now spending less time on that and just review what the AI is doing. And so in conclusion, I'd say really use the tooling you already have. So if you have already SonarQube, if you already have a tool that you can visualize data with, just use that. You'll go a lot faster than having to learn a new tool or a new language or whatever. Start small, bring value, validate, and iterate. That worked really well for us. And also in terms of communication, listening, and supporting engineers to help you on that journey as well. And so I'll finish on this graph we've had at the beginning of the talk, showing how the depth was doing, and this is how it's doing these days, which is very encouraging and very nice to see. Thank you. I don't think we have time for questions, but I'm happy to answer question here. So if you have some, please come. Otherwise, find me in the conference in the next 2 days, and be happy to have a chat on the topic. Thank you.